We can use exponential functions, as we see here, for compound interest with the compound interest formula. The amount of money, A, that a principal, P, will grow to after T years at an interest rate R, we convert this rate to decimal form, compounded N times per year, is given by the formula A equals P, parentheses, 1 plus R over N, close parentheses, to the whole exponent N times T. And there are some common phrases we see in problems. Those are compounded quarterly. That means that it happens 4 times a year, so N is equals 4. Compounded monthly, which indicates that it's compounded 12 times in a year, so N equals 12. And then last, compounded biannually or semi-annually indicates that N equals 2, or it compounds twice a year. So let's go ahead and dive into a question. Suppose that $3,000 is invested at 3% interest compounded monthly. Find the amount of money in the account after 7 years. Well, let's first identify the information we have. We're investing $3,000, so this is a P, a principal amount. That's what principal is, the amount that is invested, where A is future value, how much it's worth at the end. Let's see, we have 3% interest. 3% interest, which means that R equals 0.03, writing that as a decimal. Compounded monthly, this phrase tells us that N equals 12. And then the amount of money after 7 years, that tells us that T equals 7. So filling this information in, I have A equals P, that's 3,000, parentheses, 1 plus rate 0.03 divided by N, which is 12, close parentheses. And all of that is raised to the 12 times 7, N times T power. Now, this is money, so we are going to round to 2 decimal places. But I'm going to input this in a calculator, 3,000 parentheses, 1 plus 0.03 divided by 12, close parentheses, to the, open parentheses, 12 times 7. Yes, we often write this in this way to make sure that we don't lose anything. 12 times 7, let's see, closing all my parentheses, enter, I get $3,700. 37.064, which will round to $3,700.06. And that is the amount of money in the account over 7 years. Try one more. For example, on Jacob's 6th birthday, his grandparents present him with a $3,000 certificate of deposit that earns 5% interest, compounded quarterly. If the CD matures on his 16th birthday, what amount will be available then? Let's again identify the information we have. We have a $3,000 certificate of deposit. So that would be P equals 3,000. Earns 5% interest. So a rate of 0.05. Changing that to a decimal. Compounded quarterly. That means that N equals 4. And it matures on his 16th birthday. Well, what does that tell us? Well, he received this when he was 6. So this means that T equals 10. It has been 10 years. So now let's take our formula. A equals P, open parentheses, 1 plus R over N, close parentheses, to the N times T. This means that A equals 3,000. That's our value of P. Open parentheses, 1 plus, now we have a fraction of 0.05 divided by N, which we said is 4, it's quarterly, close parentheses, to the N times T. Well, N is 4 and T is 10. So, putting this into a calculator, 3,000, open parentheses, 1 plus 0.05 divided by 4, close parentheses, to the, parentheses, 4 times 10, close parentheses. That is approximately 4,930.858. So this means our answer is $4,930.86.